This conference will now be recorded.
Yesterday, we were discussing about what is Kubernetes, and we have done the setup. We installed Kubernetes cluster. We have set up the Kubernetes cluster, self-managed Kubernetes cluster. So today, we'll try to understand the Kubernetes concepts. As we discussed, if we want to deploy any applications in a Kubernetes cluster, we need to create a Kubernetes resources, Kubernetes objects. Kubernetes resources, or we call it as a Kubernetes objects. So before we understand what is pod, how to create a pod, and what is service, why do we need a service? Let's understand namespace. Namespace. In Kubernetes, we have a concept called namespaces. Namespace. What is namespace? Why do we need namespace? Now, you can think of namespace as a cluster inside your Kubernetes cluster. So you can think of Kubernetes cluster. You can think of namespace as a cluster inside the Kubernetes cluster. It is like you are partitioning your Kubernetes cluster. You are breaking your Kubernetes cluster into multiple teams. Right? Let's assume you have a team A, team B. Let's assume you have a team A and a team B. So they want to deploy, team A want to deploy their applications in a Kubernetes cluster. Team B want to deploy their application in a Kubernetes cluster. And they don't want to mess up each other's work. They don't want to mess up each other's work. So what they can do in Kubernetes, right, as I told already, we can break our Kubernetes clusters into multiple namespaces, multiple pieces. We call it as a namespaces. So team A can deploy their application in their namespace, and team B can deploy their application in their own namespace. It is like namespace is like you have very let's take this one. You have a one big space, one house. You take one house. So in your house, you will break your house into multiple rooms, right? Like room 1, room 2, room 3. So similarly, Kubernetes cluster, right? In Kubernetes cluster, there is a concept called namespace. So if multiple teams, multiple projects, they want to deploy their application in the same Kubernetes cluster, they can create a namespaces, and in respective namespaces, they can deploy the applications. You can think of namespace as a cluster inside your Kubernetes cluster. You can have more than one namespace, right? You can have multiple namespaces inside a Kubernetes cluster, and they are logically isolated from each other. They are logically isolated from each other. So namespaces will help you and your teams to organize and apply security on the namespace level. So if you see, already we have some namespaces, right? Let me connect to my Kubernetes cluster. Let me connect to my Kubernetes cluster. Using kubectl, we are interacting with cluster. Excuse me. namespaces is like a folders, right? Like logically will, let's take this way. You have your computer. How do you organize your files? You have a office files, you have a personal files, right? Similarly, right, you have office files, you have a personal files, you have like again videos, audio, something like that. So how do you organize those files, right? Like a folders, and you can apply a security on a folder level also, right? This is only like, only view by these users, something like that. Similarly, namespaces, you have a Kubernetes cluster. I have a Kubernetes cluster. So in that Kubernetes cluster, I can again divide that Kubernetes cluster for multiple teams. I can share that same Kubernetes clusters can be used by multiple teams, multiple projects. So we don't want to mess up each other's work. So we can create a namespaces, and the respective teams will deploy their applications in their namespaces. It's a logical grouping of your Kubernetes objects using namespaces. And also, right, then we can use as an environment purpose, like environment kind of a things. Like in the same cluster, I can have dev environment as a separate namespace, dev2 environment as a separate namespace. Namespace is basically logical grouping of your Kubernetes objects. That's it. Logical grouping of Kubernetes resources. In Kubernetes, you have a pods, you have a deployments, right? You have services. So team A want to deploy their application. Team B want to deploy their application. So you are going to organize these Kubernetes objects, these Kubernetes resources in their respective namespaces. It is not like, the container will have that Linux namespace concept. This is not the Linux namespace here what I am talking about. So this is not, I am talking about like Linux namespace. It's a Kubernetes namespace where we can organize these Kubernetes resources into some namespaces. So whatever objects we deployed in one namespace, which is isolated from other namespace. So in real time, you will have a separate clusters like dev, QA, prod. But sometimes what happens, let's take dev and, you know, maybe stage environment or QA environment. Sometimes what happens, they don't want to have a two separate clusters. They don't want to have a two separate clusters. Some projects, I'm saying most of the cases, dev will have a separate cluster, stage will have a separate cluster. But some projects, some clients, they don't want to have a two separate cluster. In same cluster, they want to have a dev one stage. In that case, what we can do? We can have a separate namespace for dev separate namespace, stage separate namespace. We can deploy the applications in a dev namespace. We can deploy the applications in a stage namespace. In that case, single cluster, you are trying to use it for two different environments. But most of the cases, it will be a separate clusters. But I see some projects, they are using one Kubernetes clusters for a multiple environments also using these namespaces concept. So if you see, as I already told, right, it is like a cluster inside your cluster. You can have a multiple. Definitely, Taranjit, it is not like a school kids or play, it is not like a play home, right? You will not use everything in a single cluster. In real time, production definitely will be a separate cluster, separate network. You will not mess, you will not use, you will not create a namespace in a dev cluster. It is not like a play store or play home, right? where we always deploy everything in a single cluster. So namespaces are logically isolated from each other. So this will help our teams to organize our projects. Now by default, how many namespaces we already have if you see? Now it is having 4 namespaces. It is having 4 namespaces. So this is namespace. Logically, they have divided your cluster. This is default namespace. This is kube public, kube system. Now, if you understand, within those namespaces, if you see within this kube system namespace, do you see some deployments are created? Some pods are there in that namespace, and services are there in that namespace. Daemon sets are in that namespace. So basically, what are these? These are Kubernetes resources, Kubernetes resources, Kubernetes objects. So in the kube system namespace, we have some deployments, some daemon sets, all those things. But all these are our own pods. I mean to say our application pods, or it's a Kubernetes system pods, or it's a Kubernetes internal pods, Kubernetes control plane pods. So in this namespace, whatever we have, in this namespace, whatever we have, these are what? These are our own application pods, or these are Kubernetes control plane pods. I mean to say that control plane, the whatever components will manage the Kubernetes. These are the Kubernetes control plane pods. Right? So these they have organized into this namespace. These they have organized into this namespace. Now, if I want to deploy some application in the cluster, is it recommended to have our own application Kubernetes resources in this namespace? Suppose I want to deploy my own application Kubernetes objects. Like yesterday, we created a pod, we created a service for our application. Can we deploy those pods? Can we create a service in this namespace for our applications? No. They are isolating. The whole purpose of namespaces is to isolate the Kubernetes resources in the cluster. So for your application, you create a separate namespace and you deploy that in that namespace. And what is this default namespace? Right? By default, our Kubernetes CTL, that kubectl, points to which namespace by default? If you see, now I am not giving that -n, something like this. So from which namespace I am getting the resources now? When I say kubectl get all, these are in which namespace? This pod is in which namespace? These services are in which namespace? This is in a default namespace. So we can organize our projects into a namespace, and also we can set the resources. We can set the resource quota. There is a concept called resource quota in Kubernetes. Resource quota. I can create a namespace and I can set a resource quota for that namespace. What is the meaning of resource here? Resource is nothing but what? Resources are nothing but a CPU, memory, and also I can set pods. How many pods can be created in that namespace? Guys, let's assume I have a Kubernetes cluster. My cluster capacity. What is my cluster capacity as of now, guys? Now I have one master. I have one master and two workers. And master capacity, master machine capacity is what? 4 GB RAM, 2 core CPU. Now worker capacity, each worker machine is 1 GB RAM and 1 CPU. So what is my cluster capacity now? My cluster capacity is 6 GB RAM and 3 CPU. Now within this cluster, I want to deploy multiple projects. Multiple teams are working on different projects. They want to deploy their applications. Now, how can I isolate the Kubernetes resources of one team from other team, or one project from other project in Kubernetes? What we can use? We can create a namespace. Team A can create their namespace and team B can create a separate namespace, and we can deploy. And also what we can do with namespace, we can set the resource quota for a namespace. We can set a resource quota for a namespace. What does it mean? So let's assume I am creating this namespace, team A. For this namespace, I can set resource quota. How much CPU can be used by this namespace? How much memory can be used by this namespace? Or also I can set how many pods can be created. How many pods can be created in this namespace? Suppose for this namespace, I have set resource quota pods. Let's say I set as 2. Just I'm giving an example, guys. I'm just giving an example. I can set pods as 2. In that case, can we create more than 2 pods in this namespace? If I set quota, resource quota, just 2 pods, can I create more than 2 pods if I set my quota as 2 for that namespace? No. And also let's say I have set memory as maybe like 1 GB. Just giving an example, 1 core CPU. In that case, whatever pods I'm trying to create in that namespace, can I request more than this memory, more than this CPU if I deploy in that namespace? Suppose I have set the resource quota, something like this. So namespaces are way to organize your applications, your teams, your projects in a Kubernetes cluster, and we can apply resource quota for that namespaces. And also security. What is the meaning of security, right? Team A developers and team B developers are there. Team A developers are there. Team B developers are there. So team A developers should not have a permissions to update, delete anything in team B namespace. And team B developers should not have any access to update, delete anything in team A namespaces. We can apply a security at a namespace level. So namespaces will help our teams to organize the application's performance and security. Namespace is a logical concept. In that namespace, we are going to create a Kubernetes resources. Is everyone clear what is namespace? Very important concept. Namespace is like we are dividing our cluster into multiple virtual clusters where we can organize our applications, our projects. Right? So while creating objects, right? Yesterday we created an object. In which namespace it got deployed? Since I have not mentioned under which namespace it has to be deployed. So which namespace it has deployed? Default. Now let me say I want to create a namespace. I want to create a namespace. How can I create a namespace? Using commands also I can create. Suppose I want to create a namespace. Using command also I can create a namespace, something like this. kubectl create namespace, your namespace name, using command. Or you can use YML. This is declare, imperative, command imperative. Now I can create using YML also. Using YML, that is declarative. So you can create a namespace using imperative command, or you can create using declarative. So something like this. In a YML, you can define what you want, right? Guys, Kubernetes is again, we are going to use YML to define. So where you have these things, these attributes: API version, kind, metadata, right? For a namespace, right? So kind, so I am trying to create a namespace. Kind is namespace. What kind of Kubernetes object you want to create? API version for a namespace is v1. Name, under metadata you have a name. This is your namespace name. What you want to give? Namespace name. Namespace, whatever name you want to give. So using this YML, you can create a namespace, something like this. Suppose let me give a namespace name as maybe something like this. Just I am giving a namespace, something like this. So using YML, I can create something like this, or using command, I can execute something like this. Namespace. Using YML, I can create a YML something like this. So here, API version v1, kind. I want to create a namespace. Metadata, name of the your namespace, something like this. Flipkart, NS, just NS stands for namespace, something like this. Whatever name you want to give, you can give a namespace. And also we can give a labels. Yes, each Kubernetes object has some API version. So for namespace, always it's a v1. For namespace, API version is always v1. Each Kubernetes object will have a API version. For namespace, v1 is the API version. So we can give a labels for your Kubernetes objects, whatever you want to give. Suppose key value pairs, whatever I want to give, key and value. Here I can say name, again labels, right? Labels I can give any key, something like this. Team name, Flipkart team, something like this. So Kubernetes objects, I'm saying, right? Kubernetes resources. In the background, this is again a code. Namespace is nothing but kind of a code, API. We are creating objects for Kubernetes resources. So we are creating a object, Kubernetes object, using this YML file. So each and every object, Kubernetes object has a versions, API versions, right? So these are predefined versions, Kubernetes versions. So if you see, right, kubectl API resources. You execute this command, kubectl API resources. If you see namespaces, what is the API version which we have to use while creating a namespace? What is the API version of namespace? V1. If you see pods, if I want to create a pod, for pod also what is the API version? V1. Suppose I want to create a deployment. I want to create a deployment object, Kubernetes object. What is the API version for a deployment? app/v1. So these are the API versions of the Kubernetes resources. If you are not sure, you can execute this command, which will display Kubernetes resources, short names, and API versions. Okay. Now we are trying to create a namespace, something like this. And also, if required, what I told, if required, what we can do of for that namespace. If required, what we can do for that namespace, we can set the resource quota. Is it mandatory to set the resource quota? No, but is it best practice to create the resource quota? Yes, because other teams also working in the same cluster. Other teams also working in the same cluster. Suppose if you don't set the resource quota, they can consume more than what they deserved. Labels are not like a group of namespaces, guys. What is label? For any Kubernetes, and like not only here, what is labels? Labels are metadata. You want to give some additional information. In Docker image also you are giving a labels, right? In AWS, you are giving a tags. Tags are nothing but what? Some kind of a key and value for additional information, for more information. Labels are just kind of a metadata to have a additional information. In Docker also you are giving a labels, right? For nodes you are giving a labels, images you are giving a labels. So that is kind of additional information, more data. Similarly for Kubernetes also you can have a labels for your Kubernetes objects, kind of additional information which will be attached to that object. Now I am just creating a using this YML. Using this YML, what I am just creating, I am just creating a namespace. These labels you can give key value pairs, like whatever. Suppose you want to give more information, any key and any value. Something like this. Any key, any value. I'm just giving example here. This key, this value, this key, this value. Like any key and values you can use. You can attach labels, additional information, metadata. So here using this YML, what I can create, what I'm creating, if I apply this YML, kubectl apply -f, There is some error. 1 second. Typo. Again. Okay. In the values, right, must be a string and consist of alphanumeric numbers. So they are not going to support this one. At the rate. Just something like this I'm giving, or let me give something. Values, they are not supporting special characters. Okay. So now when I apply this one, what happened? kubectl apply using that YML. In that YML file, what kind of object I have created? I mean to say, what kind of object I have defined? In that YML, what I have defined? Namespace. So now, do you see that namespace got created in my cluster? Do you see that namespace got created in that cluster? Flipkart NS. Now, as of now, do I have any objects in that namespace? Did we created any resources in that namespace? No. Now, we have not set the resource quota. We have not set the resource quota. So for that namespace, so can we create, like, how many parts I want to create in that namespace? Can I use, whatever CPU, whatever memory available in the cluster? Since we have not set the resource quota. Now we have not set the resource quota. Now can I create more parts? Can I take this, whatever resources I have? -f file. It is not forcefully apply. -f file. So since I have not set the resource quota, I can use whatever I want to use. But it is recommended to set the resource quotas in the real time, because since you know how many parts you are going to create for that application, right? It is recommended to set the resource quotas. How to create a resource quota? Again, in a same YML or separate YML you can take. You have to separate using 3 hyphens. In YML, one definition can be separated with another definition using 3 hyphens. Now here I am going to create again resource quota for that namespace. Something like this. I am going to create again resource quotas. Using YML, Kubernetes YML. Something like this. Again, API version. For resource quota also it's a V1. Kind. What kind of Kubernetes you want to create? So I am trying to create a resource quota. Resource quota. Then your spec, your specification for that resource quota, how much CPUs, how much parts you want to create. Your metadata, you can give a name for a, basically name for your resource quota, something like this. Name, metadata. Under metadata, you can give a name. You can give some name, something like this. Resource quota demo. And this resource quota, for which namespace? You have to create this resource quota object in the same namespace. So we already created a namespace, right? Here I am giving a namespace name. Here I am giving a namespace name, something like this. Now this resource quota, whatever I am creating, right? That will be created in this namespace. As I told, we are going to create objects in the namespace, right? Here I can set hard limits. I am setting something like this. Memory I can set something like this. Something like this. Limits. We will discuss what is request, what is limits later. Like something like this. Limits, the name itself is saying limits. I can set something like this. What is the meaning of limit? Maximum how many, how much CPU can be used in this namespace? Limit. Limit is like a maximum. Maximum how much CPU? 2 CPU. Maximum how much memory in this namespace? Whatever parts you deploy, maximum how much memory, how much CPU that parts can be used. You deploy 10 parts or you deploy 5 parts, that doesn't matter in this namespace. How much maximum it can take? 2 core CPU, right? 2 GB. And request, limits is maximum, request is kind of you are reserving this much CPU, this much memory, minimum. You are kind of reserving this much minimum for that namespace. You are kind of reserving minimum for that namespace. And also you can set the number of pods. You can set the number of pods also. How many pods you want to create maximum, something, that also. So using this YML, you can create a resource quota. Now, can I create more pods, more content? I mean to say, can I create n number of pods if the pods can take more than this much? Whatever I'm setting here, resource quota. No, guys. Interview perspective also they'll ask, what is resource quota in Kubernetes? In the interview, they are going to ask what is resource quota in Kubernetes. So resource quota is basically why we are using resource quota. What is resource quota here? Resource quota we are using to reserve or set the quota, memory and CPU and pods, right? Using this resource quota. Here I can say something like this also, pods. Now here if I say something like this, 2, In this case, can I create more than 2 pods in this namespace? No. Okay. So let me apply this. Now resource quota got created in the same namespace. Allocating resources to the namespace. We are allocating resources. In real time, how much they will request. So as an application team, you know, right? You are a developer. So you are working on one project. So if that project has, 10 microservices, and again each microservice, I mean to say each project has 10 microservice, and that microservices you want to deploy, as a Kubernetes pods. Each microservice you may need to deploy 2 replicas, 4 replicas. As an application team, they know how much pods they want to deploy. That is depends on the application team, the development team, right? So you are working on that project. You also know how many images you have. I mean to say how many microservices you have, and each microservice will be deployed as how many pods, how many replicas, right? So based on that, you will apply the quota, resource quota. So if the application team not able to deploy what they want, they will request us to increase the quota. They will request DevOps team to increase the quota. They will request Kubernetes administrators to increase the quota for their namespaces if they are not able to deploy within the given quota. Now, if you see, when I am executing kubectl get resource quota, why I am not able to see? I created a resource quota, right? Why I am not able to see? Now it is pointing to which namespace, guys? The kubectl as of now. I have applied. You see, I have applied. You see, resource quota also got created. I have applied here, and you see resource quota created. So by default, Kubernetes, this context, kubectl is pointing to which namespace? Default namespace. But I have created a resource quota for which namespace? If you see, for which namespace I have created, or in which namespace I have created a resource quota? Flipkart. Now, if I want to see that, I can use -n, that namespace name. Now, do you see the resource quota for that namespace? In this namespace, I have created a resource quota. Can you see? Something like this. Now, we have a namespace. Within this namespace, if I want to deploy my application, I need to create a required Kubernetes object. Guys, is everyone is clear what is namespace and what is resource quota with respect to the namespace? Now, we'll try to understand the next. I want to deploy one application now. In case of Docker, what we were creating, guys, to deploy, I have a Docker image, right? I have created a Docker image for my application. In case of Docker, what we are doing to deploy that application, what are we creating in Docker? In Docker, we were creating a container. Now, when it comes to Kubernetes, you are not going to create a container directly. When it comes to Kubernetes, we are going to create a pod. What is pod, right? Pod is the smallest building block or basic unit of scheduling in Kubernetes. Pod is the smallest one which we can deploy in a Kubernetes. Pod is the smallest one, basic unit of scheduling, which we can deploy in a Kubernetes. In Kubernetes, pod represents the running process. In Kubernetes, pod represents the running process. Inside the pod, you can have one or more containers. Inside the pod, you have one or more containers. Inside the pod, we can have one container or more containers. Inside a pod, you can have one or more containers. So what is common for all the containers which are running in the same pod? Inside the pod, you can have one or more containers. What is common for all the containers which are running in the same pod? Right? The containers will share the network IP, I mean to say network and storage and other specification are common for the containers. So here in Kubernetes, pod will have an IP address. Each and every pod will have unique IP address in the cluster. Each and every pod will have a unique IP address in the cluster. And whatever containers we are running in that pod will share the same IP, same storage and network and other specification. Pod is group of one or more containers which will be running on some node. Suppose I created a pod. Now pod is running on node 1. Pod is running on node 1. If that pod has two containers, I am creating a pod. Pod is running on node 1. If that pod has two containers, where those two containers will be running? Will it be running in a different nodes for that pod? Those two containers are in the same node wherever pod is scheduled. In the same node. Suppose if my pod is running on node 1, if the pod has two containers, both containers will be running on the same node. Pod is abstracting network and storage away from the underlying container. Pod is taking networking and storage away from the underlying containers. Now pod has a IP. We are going to attach storage to the pods. Right? So pod is abstracting network and storage away from the underlying containers. Each pod will have a unique IP address in the cluster. Each pod will have a unique IP address in the cluster. Again, inside the pod, what do we have? Again, inside the pod, what do we have? Pod is nothing but containers, one or more containers. Right? So again, any data saved inside the pod, inside the container, it will disappear without persistent values. Right? Suppose you are not using values. If your pod is deleted and recreated, which means your containers will be deleted and recreated. Will it have a data? Will it have its previous state if pod is deleted and recreated again? No. So again, here we have a volumes concept. So if you see this diagram, you can understand. You have a node, Kubernetes machine. In the node, what are these circles? The big circle. Basically, inside the nodes, you can schedule the pods. Pod. So pods will have what again? Inside the pods, what do we have? Container. And what is this? This icon? Storage, volume. Right? Volume. So you can create a container, you can create a pods. That pod will have a single container. This is single container pod. So this one also single container pod, and we are using storage volumes. Here, this one like a multiple containers. So pod is nothing but a group of containers, and we can attach a value storage to that pod. Suppose Here, let's take this pod. This pod has two containers and one value. So can these two containers use the same value, same storage to write the data? As I told, what is common? What is common for the containers in the pod? Can these two containers will use same storage, network and storage? Will they able to share this file system, this storage between these two containers? Yes, right? So pod is nothing but a containers, one or more containers, and you can attach a volumes to the pods. So these volumes can be used based on your requirement. You can use this volume from this container and this container. We can use the values. So Kubernetes pod represents the running process, not the service. In yesterday's session also, we created a pod. We created a service for what? Yesterday also I discussed. Don't get confused with the Docker service and Kubernetes service. In Kubernetes, we have a pod. Pod represents your container, your running process. So what is service? In yesterday's session also we discussed. What is difference between Docker service and Kubernetes service? Service is for what? Service is for accessing the pods within the cluster or outside the cluster. Service is only for a communication in Kubernetes. In Kubernetes, service will not represent your containers. In Kubernetes, what represents your containers? Your pod. So now I want to create a pod. How to create a pod? Again, yesterday we created using command. We created using command. We created using command. How did we create it yesterday? Imperative command. kubectl run your pod name hyphen image, your image name. And if I don't mention any namespace, in which namespace it will deploy? It will create this pod in the default namespace. Now suppose I want to create this in the Flipkart namespace. What I can mention? -n, that namespace name. I can create in this namespace. So this is imperative. I don't want to create using imperative. I want to create using declarative. So what needs to be written? If I want to define in a declarative way, YML. So in real time, which one we will use? You are going to directly use imperative commands, or you are going to use declarative in real time? Declarative. Because I can maintain that in my version control system, right? Can we, the way I'm maintaining my source code, we will maintain the Kubernetes manifest files in the version control systems, and you can apply those manifest files in the cluster, whatever cluster you want to apply. So now how to create a pod using manifest file? Now I don't want to create using command. If I want to create using command, this is the imperative way. Your image name, your pod name, right? Something like this. Now Kubernetes manifest file. So Kubernetes manifest file. So what are the attributes of Kubernetes manifest files? Root attributes. What are the root attributes? It's a YML again. So what is the meaning of root attributes? Whatever is starting from the beginning of the line. What are the root attributes of Kubernetes manifest files? API version, kind, metadata, and spec. Now, I am trying to create a pod. So what is the kind? What kind of Kubernetes object you want to create? What kind of Kubernetes object I want to create? Pod. P caps, guys. P caps. Pod. What is the API version? Here I have given a table for your for your understanding. Here I have given a table for your understanding. API version. Kind is pod. For pod, what is the API version? V1. So if you don't know, can I, what command I can use to see API versions? kubectl API resources. You execute this one, kubectl API resources. It will give all these are Kubernetes resources and respective API version. If you see pods, kind pod, pcaps, kind pod. And what is the API version for that? V1. So now I am creating a pod V1, V small, metadata. Metadata. So in our metadata, what do we have? Name. Here also I can directly say namespace and also labels, right? Name. So this name is for what? This name is for what? What kind of object we are creating? Pod, right? Here we will be giving a pod name, whatever name you want to give. Namespace. So here namespace name. Suppose here, now if I say something like this, under which namespace now this will be created? If I give something like this, under that namespace, Flipkart namespace. So here I can give a namespace name. Again, labels. These labels are for what? Here again, labels are key value pairs. Additional information, metadata. We are going to use labels widely in the Kubernetes. So these labels are for what? These labels are for what? For which object we are adding these labels? We are attaching these labels again. Pod. I can give key value pair, any key, any value. These are widely used. Key value. Key value. Now spec. What spec stands for? What spec stands for? Specification. Specification. So you are creating a pod. Pod contains what, guys? Pod is nothing but what? Containers and values. Containers and values. So where should I define that container information for this pod? What containers, from which image it has to be created? What is the container port? Where can I define that information? Under the specification, your pod specification. So here, containers, containers, name, name of the container, image, from which image, ports, your container port, on which port your container is running, something like this. And also, if your container has a environment variables, you will define something like this, guys. We will understand slowly. In the Docker, how you are passing environment variables for your containers? -e, while in the command. In case of compose file, how did you define? In case of compose file, how did you define environment? But when it comes to Kubernetes, if you want to pass some environment variables, I can use this one, env, env, environment, name and value. This we will slowly understand. Okay. Now, what hyphen represents, right? In a YML, as I told, array. So now, if I want to create a one more container, this section will be repeated. This section will be repeated, right? Name of the container, from which image you want to create, that container information. And also, if I want to use values for these containers, right? So there is a one more section which comes here, values, which we will discuss later. Values, right? Now, this is how I can create. Now I have this image. I want to deploy this application in Kubernetes. What is the smallest one we can create for this in a Kubernetes to deploy? Pod. Pod is the smallest one. But again, in real time, do you directly create a pod, guys? In real time, do you directly create a pod? No, you will not directly create a pod. Why? Because if pod goes down, it will not come up automatically. And I want to scale my pods. I can't scale if you directly create a pod. In real time, you will not directly create a pods. You will create a pods with the help of controllers. With the help of controllers. What controllers? We have replication controller, replica set. Again, these are the Kubernetes objects. Deployment, stateful set, daemon set, something like this. We have some controllers. You are not going to directly create a pod. Why we are not going to directly create a pod? Because if the pod goes down, the pod will not come up. And also, if I have just one pod for this application, if I just have one pod for this image, if there is a lot of load, will it able to support that much load if I just have a one pod? In that case, I need to have a more pods. If I directly create a pod, I cannot scale my pods. And if pod goes down, it will not come up automatically. We are understanding the pod concept, but we are not directly going to create a pod. With the help of these objects, with the help of any of these objects, we will create a pods. If I create a pods using these objects, any of these objects, who will manage that object, that pods? If the pod goes down, if I have created a pods using this replication controller, suppose if I have created my pods using this replication controller, if my pod goes down, will this replication controller will recreate the pod? If I have created, yes. Suppose if I have created my pods using deployment, or basically replica set. If I have created my pods using replica set, in that case, if that pod goes down, will it be recreated by that replica set? Yes, right? So using any of these objects, you are going to create a pods. But since we are understanding the pod, first, I'm not directly explaining what is replication controller, what is replica set. First, we are understanding the pod. Then we will see how to create these pods using these objects. So now I want to deploy this application. In real time, you are not going to directly create a pod, guys, for this image. You are going to create any of these objects. But for now, I am creating a pod directly. Now you tell me how to deploy, how to write a manifest file for this one. So API version, kind, metadata, spec. So now API version, kind, I am directly creating a pod. What is the API version? V1. And metadata. Under metadata, name, whatever name, you give a name, Java web app, pod, labels, whatever labels, app, Java web app. You can give a namespace also, but if you don't mention a namespace, while applying, it will deploy in whatever namespace it is currently pointing. Otherwise, I can do something like this also. In my YML, if I have a namespace, something like this. In YML, I have a namespace, something like this. In this case, the pod will be created in which namespace? If I execute this command, in the Flipkart. Suppose in the YML, I have not defined the namespace. In that case, if I execute something like this, whatever namespace it is currently pointing, whatever namespace your kubectl is pointing. As of now, which namespace kubectl is pointing by default? Default namespace. And here also I can use something like this, -n, something like this. Even though in my YML, I have not defined a namespace for this object. If I mention something like this now, in which namespace again it will create? While applying a YML also, I can do something like this. So now let me give here itself namespace. Flipkart NS. What will happen if you do something like this? What will happen? You do something like this. I think it will throw error. I think it will throw error. Otherwise, it will take the runtime. The command runtime in the sense while executing, while applying. I think it will throw error. Otherwise, it will take this one. Let me, see that. Now, spec. I am creating a pod. I am creating a pod. So pod will have what? As I told already, pod will have a containers. Containers, name of the container. You can give any name, Java web app container. Image, your registry. Can we deploy only from a public registry, or can I give any registry here? That image, any registry. In real time, we will use private registries. Okay. So later I will show how to deploy from private registries. Java web app. If I don't give again here tag, which version of the image will be used? Again, same concept, :latest. If that image doesn't exist in your repository, what will happen? Error. Image pull back off. You see a error called image pull back off. I will show that later. Now, let me give something like this. So resource quota we have given for a namespace. We have given for a namespace, resource quota. Resource quota for a namespace, but also here I can set the resources for a containers. For containers, I can set the resources. Resource quota is for a namespace. I can set the limits for the containers also. We'll slowly understand. First, we are going with the basics. I don't want to mess up everything at one point. Okay. Later, I will explain how to set the resources for a containers, because you will get confused if I explain all the concept in the beginning. Ports, right? Your container port. What is my container port in case of this image? In case of this one, it is 8080. Right? Now, for this application, we don't have any requirement to pass environment variable. For this application, we don't have any requirement to use volumes. Suppose for this image, this container, if I want to pass some environment variables, what other options I will use here? Env, environment, right? Something like this. Environment, name and value, name and value, something like this, which we will discuss later. Because for this application, for this container, we are not expected to pass any environment variables. We are not passing that. Okay. Not only in DB, guys, anywhere. In normal application also you may need to pass. But for this image, for this application, there is no requirement. No one is expecting. Not only for databases, right? Any application, if it is expected to pass, we can pass. Now, with this YML, if I create, how many parts will be created, and again that part will have how many containers? One part will be created. Within that part, how many containers? One container. So pod types, single container pods, multi-container pods. So in most of the cases, you are going to create what type of pods? Single container pods, right? Your application will be created as a pod. That pod will have a single container. But we have some cases, some requirements where we are going to create a multi-container pods. Multi-container pods. Sometimes we call it this as a sidecar. Sometimes we call it as a sidecar containers, or sidecar multi-container pods, or sidecar containers. So most of the cases it will be a single container pod, something like this, one container. But we have some cases, some requirements, right, where we can go for a multi-container pod, something like this, 2 containers or more than 2 containers, right? So pod model types or pod types. Pod model types or pod types. If you see, most frequently, most often when you deploy a pod to a Kubernetes cluster, it will contain a single container pods. But there are some instances when you might need to deploy a pod with multiple containers. There are some cases where you will deploy pods with multiple containers. So one container pod, single container pod. This model is most popular. Pod is the wrapper of a single container. Since pod is the smallest object in a Kubernetes, it will manage the pods instead of directly managing the containers. Kubernetes will manage the pods instead of directly managing the containers. This is single container pod. Multi-container pod or sidecar containers. In this model, the pod will have more than one container. A pod can hold multiple co-located containers. Co-located, which means if that pod has two containers, wherever the pod is scheduled, those two containers will run together. If pod has two containers, if pod is scheduled in node A, will the both containers will be running in the same node? If the pod has two containers, if the pod is scheduled in node 1, will both will be running together, co-located in that node? Yes. So in this model, pod can hold multiple co-located containers. Basically a primary container and a utility container. A primary container and a utility container. Suppose there is a main application, and it requires some help. So you can have that helper container in the same pod. So primary container and a utility container that will help or enhance application functions. Examples like a sidecar containers, like monitoring agents, log shippers, something like this. Or let me take this use case. So I have a main container. Let's take I have a main container. That container has a code to read the file and process that file. That container has a logic. That container has a code which will read the file from the storage and it will process that file. But suppose that file is in a different locations. Different locations. So what we can do, we can implement, I mean to say the developer can write a utility container, utility code, helper code. So that utility code or helper code also will be deployed as a container. So this synchronizer, something like this. This file synchronizer can get the files from outside. The file synchronizer can get the files from outside, wherever it is, and it will make it available in the value. It will make it available in the value. And this main container can read the file from this value and it will process. So in that case, this is my main container. It is doing something. This is helping the main process, main container. It is enhancing the functionality. Since both containers are running in a same pod, will both containers will have access to this value? Can the values will be shared? Can we share the value between these two containers? This container can write the data to this value, and this one will it able to read? Both containers are running in a same pod, so will the values can be shared between those containers? Yes. So some use cases, some requirements, we will have a multi-container or sidecar. What is the meaning of sidecar? Sidecar. Helper. Sidecar. Helper. It is going to enhance the functionality of your main container, main application. So primarily there are these types: single container pod and multi-container pods, or we call it as a sidecar. But most widely, when we are deploying applications in a Kubernetes, most widely which model we will use? Most widely we will use this single container pod, unless until you have a special requirement, kind of a helper. Now, as I told here, what is common for the containers which are running in the same pod? What is common? If you see this diagram, network, and storage. Volumes. If you attach a volumes to the pod, that volume can be mounted in this container or this container also, if you want to mount. So all the containers in the pod can have a same value mounted, so that they can communicate with each other by reading and modifying values in the storage. And also, what is common for the containers which are running in a same pod? Again, network. So sometimes in the interview they'll ask this question, guys. Sometimes in the interview they'll ask this question. How containers can communicate with each other if they are in a same how containers can communicate with each other if they are in a same pod. With each other within pod, within the pod. Communication, guys. Storage is different. Storage is different, right? And communication, accessing, right? So not with the name of the container. Since they are sharing the same network, will they able to use local host and respective port number? Local host. You don't need to depend on the pod, container IP, pod IP. If one container has to communicate with other container, if they are in a same pod, so this pod is sharing the same network. So can they use local host within the pod? If this container want to communicate with this container, do you really need a IP, container IP or pod IP? If this container, this application want to communicate with this application within the pod, will they able to use local host? Local host and respective port number. And again, can I have two containers in the same pod with same port? Can I have something like this? Two containers in the same pod with same port. The same port. We will get a port conflict, guys. You can have multiple containers. You can have a multiple containers, but the container port should be different. You cannot have a same port because both are running in a same pod. That pod is the container, the network is common for these containers. So you will not work. This will not work. So pod will have a containers for a different images. It is not like a replica. Guys, suppose I want to run two containers for this one. Are you going to do something like this? My requirement is for this image, I want to have a two replicas, two containers. Does it mean, are you going to create a single pod with two containers from the same image? No, that is not the way you are going to do. So if you want to have a two replicas for this image, this container, what do we do? You will have a two pods. You will have a two pods, not one pod with two containers. Okay. So within the pod, if there are container one and container two, like a main container and helper container, if they want to talk to each other, what they can do? They can use local host and the respective port number. Local host and respective port number. Within the pod, if one container want to communicate with other container. So this is also interview question, guys. How containers in a same pod can communicate with each other. You don't need a container IP. You don't need a pod IP. Since they are running in a same pod, they can use a local host and respective port number for a communication. So this is pod model types. This is pod model types. Now let me create a pod quickly. Let me create a pod quickly using this YML. Now, how many pods? Is it a single container pod or multi-container pod? This YML. It's a single container pod. Now, let me have this YML. Now namespace. Someone was asking, let me do this. In the YML, I have a default namespace. I have defined as a default, but while applying, I will use this one. Let's see what will happen. Someone was asking that question. kubectl apply -f, that file name, and in my YML, I have a default, but here I am using this one. There is a tab, there is a special character in that YML. Let me fix that. Line number 12. Indentation problem, guys. If you see, it is not proper. API version has been not set. There is a typo. API version. Now, if you see what it is saying, it is throwing error. The namespace from the provided object is default, does not match the namespace Flipkart NS. So it is throwing error. So in YML, you define something, right? You are passing something else. It will not work this way. Okay. So here, let me give. If I remove everything, and if I use -f, -n, it will work. Otherwise, let me define here itself, Flipkart NS. Now, while applying, I no need to again mention this. So since what I have done, since I have set the resource quota, for that namespace, while creating a parts, I am not mentioning how much CPU, how much memory is required for this pod. Is it allowing me to deploy? Since I have set the resource quota, for that namespace, while creating a pod, I am not mentioning how much CPU, how much memory is required for this pod. So do you see, is it allowing me to deploy? Because you are not setting how much this pod is required, how much CPU, how much memory is required. That's why it is not allowing. Now, how can I define that one? For my pod, sorry, not for this one. For my pod, my container, here I can use that option again. Resources. Here, there is an option here, resources. It will have two things, requests and limits. Request and limits. Requests and limits. So request CPU. I can say something like this. Memory. Let's say I want 5112. I need 100 millicore or 200 millicore or 500 millicore. Millicores, right? Limits. So this is minimum how much you need, something like this. You can mention minimum. I need 256 memory, 256 MB of memory and 500 millicore or 200 millicore. CPU will be in a cores. If I give something like this, what does it mean? 0.5. What does it mean? Half, right? Or I can say something like this. This is minimum. I am expecting this much memory, this much CPU to be available for this container. Now, what is the meaning of limit? Limit also you have something like this. Maximum how much how much it can take. Guys, can I give something like this? My Am I audible now? Yeah, there was some network issue. I switched my network. Okay. So what I was saying here, can we give something like this? My request is greater than limits. My request is greater than limits, right? Resources. I'm giving a resources. Under this, we have a two things: requests and limits. So what I'm trying to say, request, CPU and memory. This is for containers. You are saying how much memory and how much CPU you required. But in the resource quota is for what we have defined, guys. Don't get confused this resources with resource quota. These resources for what I am trying to define here, whatever I am defining, these resources are for what? Container. So for this container, how much memory I want, how much CPU I want, and how much CPU it can take maximum, and how much memory it can take maximum limit. So here I am saying something like this. I need something like this. Memory minimum, I need this much memory. Limit I can say something like this. In this case, maximum how much memory, how much CPU it can take, this container maximum 1 core CPU and 1 GB RAM. Guys, can I give something like this? Interview question. Can I give something like this? Is it valid? I am request is greater than limits. Is it valid? No. Now here I am giving something like this, right? Whatever, something like this. Now this is my container resources. Suppose in my pod, in my namespace, already there are some containers. Already they have taken some CPU and memory. If this exceeds my resource quota, will this pod will be deployed? Will this container will be deployed? So resource quota is for a namespace. You are setting a resource quota for a namespace. So within that resource quota, you can allocate. Suppose, let me deploy this. Let me deploy this first. kubectl apply -f. Now pod is created. Pod is created in which namespace? In that Flipkart namespace. Now container is getting created. I mean to say pod is getting created. And within that namespace, I have a resource quota created. Now resource quota is created. Now if you see, now what is the limit I have set for my pods? How many pods maximum I said I can create? 2. Now already one pod is there. Already one pod is there. In that namespace, resource quota, already one pod is there. So if you see request for a CPU and memory, while creating a resource quota, how much request memory I have given? 1 GB. Out of 1 GB, how much I already requested? For this pod, I requested something. 256, right? Limit is 2 GB. Now, again, if I try to create a multiple pods, can I go beyond this resource quota in this namespace? Can I create more than 2 pods? Can I request more than this? Request and limits. Resource quota is like a condition, guys. You are allocating resources for your namespace. You can't go beyond that one. Now, can I create more than 2 pods in that namespace because of the resource quota which I have set for that namespace? No. And also, let me delete this pod and again let me recreate. Let me delete and let me recreate. So now I have set request is this much, limit is this much. Can I request 2 core CPU for my pod? Can I request 2 GB memory for my pod? Since I have set this much limit resource quota. Now in my pod, can I request something like this? Maybe memory is this much. Can I do something like this? Request is this much. No, something like this. I am requesting 2 GB. But in my resource quota, in my manifest resource quota, what I have given, guys, for request maximum? 1 GB. But I am requesting how much for this pod? How much for this container? 2 GB. Now, let's see what will happen. What it is saying, guys? Is it within your resource quota, that request and limits? it has exceeded the quota. So what is the use? Now you understand, right, why we are using resource quotas. We have a control on the resources in the cluster. Otherwise, the team, the development teams, whoever is working, they can deploy how many pods they want to deploy. They can use how much CPU they want. But will that will that impact the other namespaces, other applications? If you don't have a proper resource request and limits, will it impact other applications, other pods which is running in the same cluster, if you don't properly handle these resources? Because other applications also, the resources are common. Basha, don't get confused. Limits is different, request is different. Now here, limits, how much I have defined? 2 GB in the resource quota. Request, how much I have defined? 1 GB. Now here, I am expecting request itself how much? 2 GB. Now is this within this limit? Request is minimum, limits is maximum. So since this is not within the quota, that's why it is not working. Hope you are clear now. Yes, request should be compared to the quota request, limit should be compared to the quota. Now I have given something like this. Now can I create a multiple part something like this within the quota? Suppose I am giving just 100 millicore and just 128 MI. Limits I am saying maximum 0.5. Memory something like this 256 MI. If I create this way, now can I create more pods? I can create another pod, whatever is available. The sum of request, sum of limits should not be exceeded with your resource quota. Sum of your all pods request, sum of your all pod limits should not exceed the resource quota of your namespace. So that is how it works. Okay. We'll continue tomorrow, guys. We just created a pod. We just created a pod. Right. Now, let me apply this. You can have it in a same YML also. All the namespaces, pods, everything. But namespace you will not create every time, right? Is namespace is every time you are going to create or one-time activity? Just one-time activity. So you will not create multiple times. Even though you have in the same YML, it will not give any issue, guys. It will not cause any issue. You can have in the same YML. That is also fine. If that object is already there, you will get a error. No changes. Okay. So let me deploy this pod. Now pod is created. Now tomorrow we'll continue how to access this application. Now I deployed my application. My pod is running. How to access within the cluster, how to access this pod application, outside the cluster, how to access, will continue tomorrow. So namespace will not be created automatically. You need to create. There is no internal external concept the way you have in the Docker Compose. If I don't have a namespace, I will get a error. If the namespace doesn't exist, I am creating something in that namespace, you will get a error. First, you need to create a namespace. Okay, guys, we'll continue tomorrow. try to practice whatever we discussed, right? Namespace. If you don't, if you are confused with this resource quota, if you are confused with this resource quota, don't create a resource quota. Don't create a resource quota. You just create a namespace and start deploying the pods in the namespace. You don't create this resource quota. You just create a namespace and start deploying the pods in the namespace. If you are confused with this resource quota, what is this resource quota? Thank you guys. I'm stopping the session for today. We'll continue tomorrow. Any questions before I stop the session for today? The object names, these names at a namespace level, like a namespace level, because you will not get a conflicts. Same name I can use in another namespace also. But within a namespace, the object name should be unique. Okay, guys, that's it. We'll continue tomorrow. Thank you.